Hey there, this is Mr. Alexander, and today what I'd like to do is talk to you about solving systems of linear inequalities. And what this is tantamount to doing is graphing and figuring out the solution set, which is the area that is shaded multiple times. So let's just get into it. Y is less than or equal to x. I'm going to go ahead and graph this line. I'm just going to pick a color. And I know that the line y equals x starts at the origin, and the slope in front of that x is 1. So that thing's going to go up 1 over 1, up 1 over 1, and down 1, left 1. So it gives me that nice 45-degree line. And it says y is less than or equal to, which means this is a solid line. So I'm going to use a straight edge to make this nice solid line here. I like to put arrows at the end of my line so that I know that it goes on forever. And it says y is less than, and less than means shade below. So I'm going to shade all the stuff below this line here. But then I've got this other equation. 5x plus 3y is greater than negative 6. Now I need to graph that as well. But I prefer to graph these things when they're in y equals form. So I'm going to go ahead and solve this thing for y real quick. 5x plus 3y is greater than negative 6, like that. Let me just zoom in so you can see what I'm doing here. I want to isolate the y. I want to get it by itself, so I'm going to subtract 5x from both sides. That's going to give me 3y is greater than negative 5x minus 6. Well, the y is not by itself yet. I still need to isolate it. And to get rid of 3 times something, we're going to do the opposite of that. We're going to divide by 3 on both sides. And notice that I put that divide by 3 on both the terms over here. I did that so I remember that I have to divide everything on that side by 3. Okay, so that's going to give me y is greater than negative 5 over 3x minus 6 divided by 3 is 2. So that's the equation. I'm going to go ahead and come back over here. I'm going to zoom out. And I'm just going to rewrite this equation as y is greater than negative 5 over 3x minus 2. That's what I just found. So I'm going to use a different color here. I'm going to use a green marker. And I'm going to start at the y-intercept of this one, which is negative 2. And the slope is negative 5 over 3, which means I'm going to go up 5, left 3. 1, 2, 3, 4, 5, over 1, 2, 3. And you only need 2 points to define a line. So I'm going to go ahead and make this line. But this says y is greater than, not greater than or equal to. So I know that this is a dashed line. So I'm not going to make it a solid line. I'm just going to make it a dashed line here. Like that. And I like to put arrows on the end so I know that it goes out forever. Now it says y is greater than, so I need to shade the region above that line, so all of this stuff. Now hopefully you've noticed that there's one region where we have shaded twice. This is the solution set, and it's this big triangle looking thing right here. All this stuff, this is a dashed line. All of this purple stuff here, that is the solution set. So normally with systems of equations, when you're solving for like x and y or x, y, and z. But with systems of inequalities, there's an infinite number of solutions. There's not just one point that satisfies both these equations. There's an infinite number, and it's anything in this purple region here. It's the thing that satisfies both of these equations, and there's lots of points that do that. It's all the stuff in here. So I want to show you a couple more of those. I've got one prepared here. I've got x is less than 2, and x minus 2y is greater than 6. Well, x is less than 2. I can go ahead and graph that. Any line that is like x equals or y equals is simply a vertical or horizontal line. And x equals lines are always vertical. So I always start at 2, and I just put a bunch of dots on this point x equals 2 because it's a vertical line. And I know it's a dashed line because it's less than, not less than or equal to. So I'm going to dash it, put some arrows on it to show that it goes forever in both directions, up and down. Now it says x is less than 2. Where are the x's less than? To the left or to the right? Well, they're less than to the left, so I'm going to shade all this stuff over here. Okay. Now this other equation, x minus 2y is greater than 6. We haven't isolated the y yet, so I'm going to go ahead and do that over here. I'm just going to copy it down. X minus 2y is greater than 6. And I'm going to solve for y. I'm going to start by subtracting x. That's going to give me negative 2y is greater than negative x plus 6. And the y, to get it by itself, we're going to divide by negative 2. We're going to divide everything by negative 2, every term. So it's going to give me y, got the y by itself. But whenever you multiply or divide by a negative, you need to flip it, the inequality. Flip that inequality, make that less than. Those negatives cancel out. That gives me 1/2 x. 6 divided by negative 2 is negative 3. So now I've got that y by itself. I've got an equation I can write and graph. So I'm going to copy that over here. So this equation becomes y is less than 1/2 x minus 3, which I can graph. And I'm going to do that in green. So I'm going to start by putting a big dot on the y-intercept at negative 3. And I'm going to go up 1 over 2, up 1 over 2, and down 1, left 2. This is also going to be a dotted line because it's just less than. So dash that line, put some arrows on it. And I need to shade all the stuff that's below because its y is less than. Again, the solution set is the area that is shaded twice. So it's this triangle over here. All this stuff in red. All these points, there's an infinite number of them. All of those points are in the solution set. So this is the answer. This is the solution. It's not x equals something, y equals something. It's x equals a lot of things and y equals a lot of things. But it looks like this. Let's do one more like that. Here's a tough one. 8x plus 12y is less than 4. 8x, I'm just copying it down, plus 12y is less than 24. And also I have 35x minus 20y is less than or equal to 80. Now I need to solve both of those for y. So let's go ahead and do that by subtracting 8x. It's going to give me 12y is less than negative 8x plus 24, and then dividing all three terms by 12. That's going to give me y is less than negative 8 divided by 12 just reduces to negative 4 over 3. 4 over 3x, and then 24 divided by 12 is simply 2. That's one of the two equations. The other one, 35x minus 20y is less than or equal to 80. Let's go ahead and subtract 35x. Just draw a line here. And we're going to get negative 20y is less than or equal to negative 35x plus 80. To get the y by itself, we're going to divide everything by negative 20, all three terms. It's going to give me y is greater than or equal to, I flip the sign because I divided by a negative. Whenever you multiply or divide by a negative, flip the inequality. Negative 35 divided by negative 20 is a fraction, which reduces, when you simplify and divide the top and the bottom by 5, it reduces to 7 over 4. It's going to be positive because the negatives cancel out. And then, of course, 80 divided by negative 20 is negative 4. So this is my other equation. So coming back over to my graph, this equation turned into y is less than negative 4 over 3x plus 2. And this equation became y is greater than or equal to 7 over 4x minus 4. I think I'm ready to graph this thing now. Now I've got these equations. So let's start with the green. And this one's going to be green. Put a dot at the y-intercept of 2. And negative 4 over 3 means I'm going to go down 1, 2, 3, 4, and to the right 1, 2, 3. I'm only going to be able to fit 1 point on there, so I'm going to use a straight edge. And it's going to be a dashed line because its y is less than. So I'm going to put a bunch of dash marks here. I should put some arrows at the end. And its y is less than, so I should definitely shade everything below that line. All that stuff. The second equation, y is greater than or equal to 7 over 4x minus 4. Go ahead and put a dot at the y-intercept of negative 4, and then go up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. That's a solid line because it's greater than or equal to. Greater than means shade above. So the solution set is the stuff that's been shaded twice, which is this stuff over here. That's in purple. All this stuff is your solution set. Make it nice and dark. Okay. I've got a few minutes left on this video, and since I've shown you how to graph, I thought we'd briefly talk about how to solve word problems. I'm not going to graph them, but let's talk about how to write some equations. How's that sound? For instance, here, the owner of Fred's Fish Market orders cod and salmon. He wants to buy at least 50 pounds of fish, but cannot spend more than $300. Cod is $4 per pound, and salmon is $7 per pound. Let x equal the number of pounds of cod, and y equal the pounds of salmon. Inequality number 1. Okay, so check it out. X plus y. If we add those pounds together, it should be at least 50 pounds. So that means less than, or sorry, greater than or equal to 50, because they need to be at least 50 pounds. That means they can be 60, 70, 80. And also, we cannot spend more than $300. And I know that 4 times x is how much the cod's going to cost me, plus 7 times y, which is how much the salmon's going to cost me, multiplying the price by the pounds. That has to be less than or equal to $300, because I cannot spend more than $300 there. And then you just need to solve for y like we just did to graph this thing. Let's talk about this one as well. Mr. Bloom is designing a rectangular flower garden with a fence around it. He can use no more than 80 feet of fencing. He wants the width to be at least 5 feet and the length to be at least 20 feet. Let x equal the width of the garden, and let y equal the length of the garden. So now we need to write the 3 inequalities. Here's how we're going to do that. Well, I happen to know it's a rectangle, and I know that rectangles, to find the perimeter, which is what we're talking about with fencing, is 2x plus 2y. And that perimeter has to be less than or equal to 80, because I only have 80 feet of fencing. I can't do 81 feet because I don't have enough boards to do it. Also, I know that the width has to be at least 5 feet. So I'm going to say x, the width, is greater than or equal to 5, because that means it could be 6, it could be 7, it could be 8. And I know that the length has to be at least 20 feet, so I want to say y has to be greater than or equal to 20. And then you would just need to graph these and to find the solution set. Okay, that's it. Thank you for watching. Have a great day, and we'll see you next time.